Hello, and welcome to another episode of Real World Analytics, What Schools Don't Teach You. This is another installment of my coffee series where I grab a cup of coffee, find something interesting, and give you my opinion as a data analytics professional. Today I want to talk about a post from my friend Jahan, I'll put a copy of it here, where he asked the question, if you're new to data science and analytics, which should you learn first? Excel, SQL, Python, or R? And in his opinion, it should be Excel. Now, I agree that Excel should be up there, but I've made a comment on this, which you can see here, that while SQL and Excel should be first, I personally think SQL should come first. And I think SQL should come first because that's a position I'd rather be in. I'd rather market myself toward organizations that use databases rather than ones that don't. And I would rather be more specialized in SQL rather than a generalist in Excel. It's one of the few cases I'd rather be more of a specialist than a generalist. But if you're interested in hearing more about this and you'd like to get yourself a cup of coffee or some other beverage, if you hit the pause button, I'll wait for as long as you'd like. So let's talk about this in a bit more detail. He says Excel hands down. He then goes on to say that he pretty much dismisses all analytics jobs that focus on Excel as non-analytics. I disagree with him, but because I know Jahan personally, I'll wait until I talk to him before I give you more opinions on why I disagree. So he talks about Excel and says if you're going to use Excel, you should know index match, VLOOKUP, some of these other rather, shall we say, advanced topics. And there's a number of reasons for this, why you should use Excel first. First of all, it is largely ubiquitous, or it is ubiquitous, I guess. Most places have Excel. It'll be expected if you're in analytics, you understand Excel. And it is quite powerful. While I don't recommend it, it is possible to code up machine learning straight in Excel using tools such as the solver, using plugins, using some other mathematical constructs. You can do quite well in Excel. And for many organizations, it is a complete solution. That is, their data are stored in Excel. A lot of their calculations are done in Excel. A lot of their projections are done in Excel. And as it happened, there was an article in the Wall Street Journal, put some headlines here, that the first rule of Microsoft Excel is to not tell anyone you're good at it, because spreadsheet experts face a constant barrage of requests for help and you may want to run away. And if you're looking for a job in analytics, you might say, well, if that's a good thing. I want to be important. I want to have everyone looking to help. And then as a kind of example as to why this is bad, they give an example Excel query here that even counting where all the parentheses close to me seems unpleasant, shall we say. Now that said, I am in a rather fortunate position where I have a job, I do work in analytics, I can be picky. If you are in a position where you are looking for any introductory job in analytics, if you're struggling to feed your family, that's different. And for those reasons, I would recommend learning Excel as quickly as possible. Now, the difficulty with learning Excel is because there are so many people out there who use Excel and because it's pretty much everywhere, you somehow need to differentiate yourself, who's going to be this Excel expert, from some average chump that uses Excel for very simple things like calculating averages, maybe applying some formula, not even getting into the more advanced concepts like Jahan's talking about in terms of VLOOKUPs, index match. Pivot tables are on the list. A lot of places use pivot tables, making graphs. So if you're going to differentiate yourself and say, no, I'm not just some casual who knows Excel, I'm an Excel expert. And you need to reflect that on your CV or your LinkedIn profile or whatever. So how can you do that? Well, there's a few options. First of all, you can start mentioning the tools you use by name. So if you include VLOOKUP, index match, pivot tables, graphs, etc. on your CV or your LinkedIn profile, or even better, if you can mention when you use those tools in order to solve business problems, or even if it's just some school problem, fine, do that. Learning Solver is a very good way to do it. And Excel 2016 has a lot more capabilities. As a casual user, I'm not really sure how these work, but if you look at, say, Excel 2016 under the Data tab, it includes ways to connect directly to a database. Now, in order to connect directly to a database, that leads me to the next point, which is learning SQL. So if you want to get data into Excel, notwithstanding how these functions in 2016 work, a common way to do so is to learn SQL. And so in order to get the data, you first need to use SQL. Now that implies that Excel isn't the complete solution, but there is some database there. And that's why I made the comment that I prefer to learn SQL first. I would much rather be in a situation where there is a database, I need to pull data from the database. But again, if you're really concerned about getting an entrance to analytics, Excel's the way to go. So you're learning SQL. For many people, this might be your first ever programming language. And it's hard to know when, say, you're getting into analytics, where are you currently? If you know nothing, you don't know any programming, SQL is a good place to start. It's fairly straightforward. There's not a lot of verbs. There's not a lot of syntax. So it's a good place to start. Now, because it implies there's a database on the back end, most of us don't have a database that we can start playing with. So there is the SQLDF package in R. Of course, you can download R for free. You can download the SQLDF package for free, and you can start using some of the built-in data sets in R in order to practice your SQL. The SQLDF help file is pretty good about giving examples. Now you may say, well, if I'm using SQLDF in R, why don't I just learn SQL in R? Okay, that holds, but the same arguments are going to come up that I started this video, that if you're going to start using R, well, you need to get the data into R somehow. And if you're using R and you want to pass that off to management, sometimes management doesn't know R and they want things in Excel. Or if you're verifying someone else's work and you're coming up with problems, because Excel is ubiquitous, you convert all of your logic to Excel and then you can compare that way. The other reason to learn SQL is because it is more specialized, as I was talking about before. And once you say that you know SQL, that limits your competition. There are fewer people that know SQL than know Excel, and you don't need to specify that you're as much of an expert. If you do want to become an expert in SQL, there are yet more options that open to you. In many organizations, SQL is production level. So if you get monthly statements, often those are driven by a SQL query on the back end. So all those doors all those doors open as options. And as much as people talk about using machine learning, analytics, etc. for marketing purposes, all that's great and stuff. But if you want to see something really important to an organization, if that model breaks, well, that's unfortunate. If your end of month reporting breaks, and you can't send out the correct monthly statements to people, for instance, that tends to get a bit more attention. So learning SQL for production level code is an option. And then also from learning SQL, you can start to build different tools and different techniques. Because SQL is text-based, you can start putting it under version control. You can start commenting your code. You can start to learn some of these other tools and techniques that aren't specific to SQL, but will be useful for text-based programming in general. And SQL, because of the way joins and stuff work, it's a good foundation for starting to visualize your data. It's a good idea to say, well, I've got this data here and that data there. I need to join them together. How is that going to work? You can start to learn some tricks about implementing more complicated logic, because if you aren't in a case where you have an Excel command like that, to be fair to Excel, if the logic is that complicated, you're going to need something complicated in order to reproduce it and to do the calculation correctly. So using SQL, you can start to learn a few more of those tricks. And finally, while I think the first two you should be learning are SQL and Excel, there is the option of learning them both together. Now, for many organizations, this is how things work. There's data in the database, you use SQL to pull it into Excel. Within Excel, you do whatever you like with it, you play with it, you filter it, you whatever, you make graphs, and then you get to a point where you have the graph you want. Okay, now you can go back to your SQL query and redefine your pivot table in SQL, and you can start to see how these two connect. So you pull down all your data, hopefully it fits in Excel, you do all your processing, you say, right, this is the graph I want. You go back to your SQL, you optimize your SQL so that the database is doing all the work, not SQL, and you get that graph out. And this can start to lead into building dashboards, building shiny apps, building some of the other things that are going to be useful to communicate as a data analytics professional with management. So I highly encourage you to reach that stage of working. So that's pretty much a larger explanation as to why I think that you should learn SQL First. I hope you found it interesting at least. If you agree or disagree, feel free to leave a comment down below, and I'll see you next time at Real World Analytics, or What Schools Don't Teach You. Thank you.